All right, guys, we are back, and we are back with Sage Review number 3. This is our last Sage Review. This is Unit 5 and Unit 7, okay? So this first question, this is going to go back to sort of just analyzing graphs and understanding where they're increasing, decreasing, max, mins, positives, negatives, y-intercept, zeros, all that kind of business, okay? So we came up with a good method of doing this in class, and we're going to do that exact same method here. So really what we're going to do here is we're going to do this up here where it's increasing, and we're going to do all of these all as one problem with our answers being over there, okay? So to start, we're going to figure out where it's increasing. And the way that we decided to do this is we're going to bust out some other color markers here. We're going to decide that, so this is like, we have to think about increasing, decreasing, and positive, negative. Imagine you're riding a roller coaster and you're always starting on the left all the way out at negative infinity. Okay, let's get that labeled, and then positive infinity is at the right. So if we were riding this roller coaster, this would be the fun part, right? We're going down, woo, and then we hit the bottom. So we're decreasing, we're going down. So right here, and then we hit a bottom at this point right here at -1. So I'm just gonna do a dotted line, and then we hit like a little bump in the roller coaster, and we're going back up. And then we hit a little peak right here, okay? So we have another one. We don't even really need to necessarily put it because that's right on the y-axis. And then we're going down again, and it's awesome. And then we hit another little valley here, okay? So really we're putting our cutoff points for increasing, decreasing at our peaks and our valleys. Okay, and so then what we're gonna do is we're gonna kind of segment this off down here at the bottom. And we have all of our different segments, and now we're gonna give these labels for the x intervals, and we're gonna put increasing or decreasing, okay? So way out here, this is gonna be negative infinity. And this is -1, this is 0, this is +1. Okay, again, these are only the x values that I'm labeling here, and then positive infinity way out over here, okay? So positive infinity. So when I'm going from negative infinity, which would be like all the way out and up there, all the way to here, I'm decreasing, okay? This was our fun part of the roller coaster, that first big drop, we're decreasing. Okay, so I'll put a D for decreasing. Then between -1 and 0, we went up a little bit, we were increasing. Okay, so being on an increasing interval, I'm gonna put I here. And then we got to the top of that valley, and then we started going down again. We started decreasing, so we'll put another D. And then we hit the last little valley, and then we started going up. And I guess this is like a roller coaster that has rockets on the back because it just launches you up in outer space or something. So you're increasing all the way out to positive infinity. Okay, so now we aren't asked to find the decreasing intervals. What this question, the first one, was asking for is where we're increasing, okay? So where we're increasing, the first thing that we should think about is this answer going to be in an interval or an ordered pair? Well, I already told you guys this is x intervals, okay? So x intervals. You know what, let's go back to, let's use, how does pink show up? X, yeah, why not? X intervals. Okay, so our answer is going to be, so we are looking for is increasing. We have two intervals of increasing, right? So our first interval is from -1 to 0. So I'm going to start with that, -1 to 0. And then we have another interval, so I have to put a U. So in union with, we're increasing from 1 to positive infinity. So 1 to positive infinity. Okay, so these are our x intervals, let's remember. Okay, so now before we get on to the next ones, and we do all these, let's just think of if our answer is going to be intervals or ordered pairs. And remember that x intervals, this is x1, comma, x2. Okay, how about maxes and mins? These are going to be ordered pairs because these are single points where we have a max or we have a min, okay? So these are going to be ordered pairs. And I'm just going to write OP, ordered pair. Okay, ordered pair, OP, x, comma, y. Same thing for min, ordered pair, x, comma, y. Okay, so now asking where the function is positive and negative, we're going to go, these are going to be interval notations again because we want to know like the interval where it's positive and negative. Where is it above the x-axis? For what values is it above the x-axis? What x values? We don't care about necessarily the y values because the y values are what we're asking for here. Positive y values, or negative y values, okay? So these are going to be x intervals with, x1 comma y, or x1 comma x2. And then same here, x intervals x1 comma x2. Okay, now y-intercept and zeros, again, these are going to be single points. Okay, so these are going to be ordered pairs, ordered pair, x comma y, x comma y. Okay, and if you have any questions about why I decided to pick each of these for each of these, we can go back to our notes and maybe just think about it a little more. I can explain that in question and answer if needed, okay? So let's go back to what's next in line. We figured out increasing. This was our x interval for increasing. Now let's figure out our max. So we have only one local maximum, and it's going to be right here in the very middle. We haven't gone left or right at all. We haven't gone up or down at all. We're right at 0, 0. So our maximum is a local maximum at 0, 0. Okay, we could also say that it's like positive infinity because on the ends it goes up forever, but we have a local maximum right here at 0, 0. Okay, and then we're going to have two local minimums, and these are actually going to be our extreme minimums because we never get below this point, right? That's the lowest point of our roller coaster, and we never get below this point. Okay, and let's remember, these are ordered pairs, so we're going to have two of them. Our first one is going to be -1 comma -1. I picked my x value going left and right. I picked my y value going up and down. I went to the left 1, x is -1. I went down 1, y is -1, okay? And we're gonna have one more point, so and our second point for this value right here, we went to the right 1, so our x value is gonna be +1. And then again, we went down 1, so our y value is -1. Okay, so those are our two minimums. All right, so now we're going to be back into our intervals here for positive and negative. So to do this, let's bust out the green marker. And the same way that we kind of decided on some cutoff points for increasing, decreasing, let's imagine that we're at ground level here. This is ground level. Anything below ground level is negative. Anything above ground level is positive. So you imagine you're on a roller coaster that goes underground. Okay, so we care about where that cutoff point is, where you go from being above the ground to underground. So one of those is going to be right here. Another one, so we actually touch the surface right here, so we're going to count this. We touch the surface here, okay? And I'm going to get into that once we get to that. And then our last one, right here, we go above ground. So if you're on this roller coaster, you started out way up high above ground, and then they built these cool tunnels, so you went all of a sudden underground, and you're underground for a while, and then you just basically get right up to the surface, you don't go above it, and then you're back under, and then eventually you come out and you're above ground again, okay? So let's just figure out, the same way we did labels here, let's put labels up here, okay? So we'll erase a little bit on each end, and we're just gonna kind of come through, and we're gonna give our little intervals segments. We're gonna break them up, okay? So we start out with -infinity, that's all the way out here, okay? And again, like I said, we started out way up high, we were positive, we were above the ground, so we were in the positive. Our interval was positive at that location. I'm stumbling over my words here, as it happens sometimes, okay? And then we went negative. We were below the ground for this interval. We were below 0 right here. So let's put an N for negative. And then we hit the surface right here. So we were not positive or negative at this one single point, okay? But then we went right back to being negative, okay? So negative down here. We were negative, 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 and then we came busting up out of the ground, and we were positive again, okay? So, and then the positive infinity is here. We did things a little sort of out of order based on how we did them here, but now we can go through and give labels to each of the cutoff points. So -infinity, this cutoff point happens here at the x value of -1.5, about -1.5, okay? This is at 0, the x value of 0. X value here is +1.5. And then positive infinity, okay? So we had -infinity, 1.5, -1.5, 0, +1.5, positive infinity. Okay, so now to find where our positive intervals are, we're gonna be looking at these two intervals, here, okay, and here. So this interval, the numbers that are around that interval are -infinity and -1.5. Okay, so I'm gonna put that, -infinity to -1.5 in union with, because I put that union with saying like basically we have another interval. We're positive from positive 1.5 to positive infinity, okay? So 1.5 to infinity. All right, so we're done with positive. We figured that out, we're feeling good. Okay, so now let's go back to negative. So the negative interval, even though these are right next to each other, we have this point at 0 where we touch the line. And when we touch the line, that means it's not positive or negative, because 0 is not positive or negative, it's just 0. Okay, so we're still gonna have to put this as two intervals, basically showing that we're not counting 0. We're going all the way up to 0 without counting it. Okay, so our first interval is gonna be negative 1.5 to 0. So I'm just gonna put that there, negative 1.5, whoops, not to infinity, to 0. In union with, our next interval is from 0 to 1.5. That's our next negative interval. So 0 to 1.5. And that's it. We're done with our negative intervals. Not too bad, right? Okay, so y-intercepts. And again, I'm talking fast, I'm going fast. That's because you guys, you can even go and people have said that I talk too fast in class. You can do something kind of funny where you can go into the settings and decrease the speed of the video, and it'll sound like I'm I don't know, under the influence of something, because the voice goes really slow and it sounds hilarious. Anyway, we'll get back on track here. The point is you can slow it down, you can go back if I'm going a little too fast, okay? So, y-intercept, this is just gonna be an ordered pair where we touch the y-axis. Okay, and we already figured that out. We found it for a different answer, but it's gonna be right here at 0, 0. So 0, 0. That's the only place on all of this where we actually touch the y-axis, okay? So our zeros, these are otherwise known as x-intercepts, X-I-N-T. Okay, so our x-intercepts, those are gonna be ordered pairs, and this is everywhere that we touch the x-axis. There's 3 points here, okay? Everywhere that we touch the x-axis. So our first one is going to be negative 1, 0. That's what makes this a 0. Negative 1, 0. Because negative 1.5 is what it should be. Negative 1.5, 0. Okay, so that's where the first place we touch the x-axis, okay? We go over to the left, negative 1.5, and we don't go up or down at all, which is why we're at 0. Okay, our second one, again, we've got another 0, 0. That applies here as well. 0, 0. And then our third one is going to be over here at 1.5, 0. Okay, so positive 1.5, 0. Okay, and so this is our answer. These questions are pretty long, but yeah, we basically filled out everything we needed to fill out for what we had here, okay? So I'll leave that up there for just a second. Let's make sure we've got a good view of everything. Yeah, I think it looks pretty good. It's pretty clear. So I'll erase it and we'll move on to 5B. Okay, how far into the video are we? We are 13 minutes in. That took a while. Okay, the next one is pretty easy right here. And you know what? I'm not even gonna do this one on the board. I'll just put it up here and I'll just talk you guys through what my reasoning was with it, okay? So we started out with the function f of x equals x to the second power that's been transformed below, okay? So I needed to come up with an equation to figure out what the transformations are. So looking at it, the idea here is that a normal parabola is gonna be going up. So a normal parabola would start here and it would go whoop and whoop up like that, okay? So because this one's upside down, the first thing that happened is we had to put a negative in front. Okay, and then we needed to figure out our x and y translations. So we went to the right, 1, 2, 3, we went positive 3. But remember, x's do the opposite. That's why there are x's, right? So I go x minus 3 inside. That's our horizontal translation. And then we went up 1. Okay, we went up 1. Y's don't do the opposite. Y's do the same. Okay, so we went up 1 for y there, and that's basically it, you guys. This one was pretty straightforward. The translation is just moving to the right 3 and up 1. So that's why I have x minus 3 plus 1. And then we had to use the negative out front to just flip it from being up to going down. Okay, so there's 5A. Don't even need to think about it. We can flip over to the next page. So now the rest of this is Unit 7 stuff. Okay, so we're gonna do all of these for Unit 7. And that's gonna be it, and then I'm probably gonna be done making videos for the day. Making like an hour and a half worth of videos for you guys today. How fun. I'll be back for more next time. I'm excited for next week when we're in here making videos, because that's going to be brand new stuff that I'm going to be like super jazzed up about. I'm probably going to tell you guys stories about like the class that I took in college that really made me just love trigonometry, but we're not going to get to that quite yet. That'll be next week. So before we get to that, and all this is Sage Review number 3. I am slacking. Sage Review number 3. Okay, so we are on to 7B. 7B. Okay, so we're right here at the top, and we care about the vertex of the function g here. Okay, so we're given two functions. We don't even care about f of x. The only thing we care about is g of x. So g of x equals x plus 3 squared minus 5. You know what? I just realized, just going back to 5a for 1 second, I made a little mistake. That happens sometimes. Okay, so going back to 5a for just half a second, really the translation looks like that. I just added a little second power there. That's what I had missed on it. So if any of you saw that and you're like, Mr. Thompson, you screwed up, sorry guys. Every now and then that'll happen. You don't need to be perfect in life. Okay, so what we need to do here is we're trying to find the vertex. Okay, so I'm going back over to that problem. I'm finding the vertex of g, so the vertex of this function. And all we're really doing here is we're doing exactly what we just did on the previous page, but we're kind of thinking about it backwards. Okay, so the vertex is going to be the point x, comma, y. Okay, and it's going to be, if I were to graph this whole thing, it would basically look like, I don't know, we would go, so because it's plus 3, it'd be kind of like this. Okay, so we go, the vertex is going to be this low point right here. And we figure out what the vertex is because it's going to be this number, but we have to remember that x's do the opposite, so our x value is going to be from here. And really, let's say we can even give this a different little label. We can call this like h, comma, k. And we can sort of visualize this as x minus h squared plus k. And so we're trying to find h and k. Okay, so because we've got 3 here, but x's do the opposite, so really, our h value is going to be -3. And our k value out here, our y value that we care about for our vertex, is going to be -5. So -3 comma -5. If you were to go in and graph this in a calculator, let me grab one real quick and see. I really need to figure out what's going on with the calculators here. None of them are working. I don't know why. I guess all the calculators got coronavirus. But anyway, this is our vertex, okay? Our vertex is at -3 comma -5. If you don't believe me, go to desmos.com, any like graphing website that'll help you out with graphing math stuff. Put this equation in, and you'll see that the vertex is going to be -3 comma -5, okay? So that is our answer for 7B. All right, now we're going to go up to 7A, and I'm actually a little bit excited about 7A here, because I learned a new trick. Shout out to Miss Lori. I learned a new trick for completing the square that I think makes it a lot easier. I wish I had known this when I taught you guys originally, but that's kind of what's nice about going through reviews like this is you learn, like I learn new things, and then I can teach you guys new ways to do it. So that way, those of you moving on to Math 3, 3 honors possibly, you'll have better ways to do things, okay? So we're completing the square. This is 7A. We've got 3x squared plus 6x minus 4. Okay, so the first step stays the same. The first step is to kind of get these on their own in parentheses. 3x squared plus 6x, leave a blank space and go minus 4. Now we have an extra little step because we need to factor something out of both of these terms, okay? And the biggest number we can factor out is going to be 3. So I'm going to have 3 and then x squared. 6 divided by 3 is 2. So 3x squared divided by 3, that's x squared. 6x divided by 3, that's 2x, okay? And then we still have this. Okay, so the trick that Miss Lori taught that I think is really awesome, that I'm going to definitely teach this way next year, is we're going to use the box again, and we're going to fill it out a little differently. So we're going to start by putting this here. That stays the same. But what is different is now we're going to fill these in, these squares, by cutting this in half. So what's half of 2? 1. So we're going to go 1x, 1x. And then to get the number that goes here, I multiply these numbers together. 1 times 1 just gives me 1, okay? So I basically, what I just did there is I cut this in half and put it there, and then I added 1. So because I put plus 1 here, I put plus 1 here. Okay, but now I have to cancel it out by doing minus 1 here, but really, this is 1 times 3. So this is kind of a tricky problem because it's got everything in it. But really, so out here, to cancel out doing this 1 times 3, I'm going to do a minus 1 times 3. Okay, so now I can factor out my rows and columns. X plus 1, x plus 1. Okay, I can just factor out x's here and here. I can factor out 1's here and here. So now this is x plus 1 squared. Okay, because it's x plus 1 times x plus 1. And then I finish the math out here, so this is going to be minus 4 minus 3. So really our answer is x plus 1 squared minus 7. Okay, so that's how we complete the square in a little bit of an easier way, I think, using the box. And if I were to, here's a little extra question, if I asked you guys, what's the vertex here? We'd go back to like the way we thought about the previous question. Well, it's going to be the x value is going to be in here. It's going to be -1, comma, -7. That would be our vertex. Okay, so let's finish up 7C. Where are we at on time? 21 minutes in. We're all right. We'll probably go towards closer to the 30-minute mark on this video, but that's fine. We'll do 7C now. Okay, so we're going to go through this one. This is kind of putting a lot of the stuff we've learned all together. So that was 7A, and now we are doing 7C. Boom goes the dynamite. Okay, 7C. We've got this big graph, and it's a big loopy parabola that kind of comes up like that. And the important things are to see that we cross the x-axis at these two places, okay? We cross the x-axis. Let's get focused. I gotta tell my paper the same thing I gotta tell like who's someone who falls asleep in second period. Cole, you gotta focus, buddy. Okay, so we cross the x-axis here at -5 and at +3. Okay, so -5 and +3. So the first thing I'm gonna do is I'm gonna start by writing an equation. X equals -5 and x equals +3. So this is where I'm starting. -5 came from here, +3 came from here. Okay, if you didn't notice that, go back like 10 seconds on the video and you will see it. So now we're gonna move this over here and we're gonna move this over here and we're gonna have the factored form of an equation, okay? So I'm gonna add 5 to both sides and I get x plus 5 equals 0. And then I do -3 here on both sides and I get x minus 3 equals 0. Okay, so now I can kind of put these, this is part 1 and part 2. We did this in the last stage review. We can basically do x plus 5 times x minus 3. Okay, so now we can multiply using our box and we'll end up with a quadratic equation. And then there's going to be one more little step, okay? So we've got x plus 5, x minus 3. X times x is x squared. -3 times x is -3. X times 5 is 5x. 5 times -3 is -15. I pull everything out and I combine my like terms. I can have x squared. Whoops, and this was minus 3x. I forgot to write the x there. So 5x minus 3x is going to be plus 2x, and then minus 15. Okay, and so we're not done quite yet. And the reason why is because we're given a third point here, and we need to figure out, there's going to be a coefficient that goes in front of this, okay? So that third point, 2 comma 28. So what we're going to do with that is I'm going to take this equation, and let's remember that f of x is, that's kind of like just saying y equals, okay? So y equals, and because of that third point, we're going to have to write a as a coefficient times x squared plus 2x minus 15. Okay, so now I'm going to use that third point, 2 comma 28, and I'm going to plug it into this equation. So 2 comma 28, what this means is x equals 2, y equals 28. And with doing this, we're going to be able to solve for the unknown variable a, okay? So let's take 28 and put that in for y. So 28 equals a times, well, I'll put, where I see x, I'm going to put 2, so 2 squared plus 2 times 2. Again, where I see x, I'm putting 2 minus 15. Okay, so now let's simplify what's inside the parentheses. So we'll go 28 equals a times 4 plus 4, so minus 15. 4 plus 4, that's going to be 8 minus 15. This will end up being, simplifying all this, 4 plus 4 minus 15 is going to give us negative 7. Okay, so I got 28 equals a times negative 7. Okay, now the last step to solve for a is divide both sides by negative 7. Okay, so I end up with negative 4 equals a. And negative 4 came from doing 28 divided by negative 7. Do that in your calculator, you'll get negative 4 equals a. Okay, so this is not necessarily our answer, but now we're going to plug this back in, the whole thing, and we're going to have like an answer that makes a little more sense. I'm kind of creeped out because there's something going on out in the hall, and I'm here like all alone. So this is like the start of a horror movie. Let's get through this example. If I don't upload this video, I guess you guys will never know because I don't upload it. But it means maybe I got murdered here at the high school. But I think we're going to be okay. All right, so our final answer is going to be y equals, and where I see a, I'm going to put negative 4. So negative 4, and then parentheses, all this business. X squared plus 2x minus 15. And I'm okay with you leaving an answer like this. That's totally going to be okay. But just for, just for fun, I'm gonna distribute this negative 4 through everything. So y equals negative 4x squared. 2 times 4, that's going to be minus 8x. Negative 4 times negative 15 is plus 60. Okay, and so either of these answers work. And what I like about doing that and actually plugging everything in is that now I can kind of see something that really makes a lot of sense to me with this question. If I notice that, let's see, I've got my y-intercept. If I were to say, how do you find it? It's going to be that 60 right there. Okay, so when I look here, my y-intercept, well, look at that. We did it right because we crossed the y-axis at about 60, okay? So we're good there. We did that question correctly. Okay, so let's flip over to the third page. We're getting through this entire review in one video. This is Sage Review number 3. We're gonna do these last 2 questions and that's gonna be it. So this video will run a little long, but remember I'm gonna timestamp it and everything so you can just kind of quickly go between whatever questions that you maybe need a little touching up on. Okay, so 7B. Let's remember again, you guys, this is basically like a whole entire class worth of work. So this is kind of like a good thing to maybe not necessarily need to be in class for because it's a lot of review. We're not learning a ton of new stuff. We're not actually really learning hardly any new stuff. But yeah, so you guys can just use the video, click around, and it's going to be awesome. Okay, so what this question is asking for, given the following function, find the requested form and tell what information you found to aid in the graphing process. Show all steps. So we start, this is 7B, and so we start with f of x equals 27 minus 12x plus x squared. Okay, and so this is not in standard form, but we have everything we need to get it into standard form. And really to get it into standard form, let's remember that standard form is f of x equals ax squared plus bx plus c. So all we need to do is swap, just basically mirror this exactly, okay? So our standard form, and I'll start right here on the left. Okay, our standard form is going to be x squared, so f of x equals x squared minus 12x plus 27. Okay, and there's our standard form. All I did is I put this out in front and I put this in the back. Negative 12x stayed the same in the middle. So what do I get from this? Again, what I get is my my y-intercept. And I get my y-intercept by saying that x equals 0 because when we think of this graphically, you know what? We'll graph it over here at the end. Can y'all even see that on the video? If I see that graphically, yeah, you can. Okay, cool. Okay, because what we're asking here is when I don't go left or right at all, I'm on the y-axis. And if I don't go left or right at all, what that means is that x equals 0. So if x equals 0, that means this is 0, this term is 0, and I'm left with positive 27. So what I'm given here, this tells me the y-intercept. So it tells me y-intercept. And that's going to be an ordered pair, and it's going to be 0, 27. Okay, and so we have room to graph here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be a little tricky. I hope you're paying attention to the video right now, because the way I'm going to graph it is up and down, we're going to go by 3. So each tick mark is going to be 3. And that's just because we go up pretty high here. Left and right, we're going to keep it all as just 1, okay? So my y-intercept, if I'm counting by 3s, I'm going 3, 6, 9, 12, 15, 18, 21, 24, 27, okay? So this is my y-intercept at 0, 27. Okay, great. So now the next thing is going to be factored form. Okay, well, we know how to factor quadratics. We've done it almost literally a million times by now. Okay, not literally, but we've done it a lot. Okay, so I take x squared from my standard form, I put it here. I take 27 from my standard form and put it there. And now we multiply across the diagonal, 27x squared. And we're going to put all our factors for 27. This is going to be 1 and 27. 27 divided by 2 doesn't work. 27 divided by 3 works. That gives me 3 and 9. And those are the only factors for 27, okay? Because it's positive 27, I put a plus sign. Okay, this gives me positive 28, and this gives me 12. Well, 12 is what I was looking for, right? But I want negative 12. So all I got to do is make all the numbers negative. Just flip the sign for all the numbers. So now negative 3 can go here as negative 3x. Negative 9 can go here as negative 9x. Okay. So now I factor my rows and columns. We're going to factor the top row, we can take out x. Factor the bottom row, I'll end up being able to take out a 9. Okay, that's going to be the biggest factor between 9 and 27 is going to be a 9. I cannot take out any x's because 27 does not have an x to give, okay? First column, I can factor out x. Second column, I can factor out 3. Same reasoning. The biggest number I can factor out between both two is 3, and I cannot factor out an x here, okay? I've got negatives on the diagonals. Negatives on the corners, that means that I'm going to have negative here and negative here. So our factored form is x minus 3 times x minus 9. And this is f of x. Okay, this is our factored form. Okay, so what does this tell me? This tells me my zeros, or my x-intercepts. So it tells me zeros. And again, if I were to go through the math, I would find out that my zeros are going to be a positive 3, because remember, x's do the opposite. We could solve for, we could part 1, part 2, x minus 3 equals 0. Solve for x, we're going to end up with our zeros equal 3, 0, and 9, 0. Awesome, so now we can put these on our graph. Okay, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3, 0. And 9, 0. So 3, 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay? So this is kind of making sense, because if I can visualize how the graph would eventually come down, I'm going to have a vertex somewhere in here, and that's going to be the third part, is getting the vertex. Okay, and we're going to do that by completing the square. So vertex form. So the vertex, I'm hoping it's going to be, the x value is going to be some positive number, and the y value is going to be some negative number. That's how I'm going to know that I did it right here. Okay, so what I have to do to get vertex form is I start with standard form, or we're going to use that new completing the square method we learned about earlier in the video. So x squared minus 12x, and then we're going to leave a space here, and we're going to do plus 27. Now because I have just x squared here, I don't actually have to divide anything out. So this is going to be a little simpler than the last one. Okay, but again, we're going to do the new method that I think is much more straightforward. It's easier to visualize. We start by putting x squared here. The next step is we're going to fill out these two squares by cutting this in half. So negative 6x and negative 6x. And when I say cutting it in half, I'm saying 12 divided by 2. We cut 12 in half. 12 divided by 2 is negative 6. So those go here and here. Now the way that I'm going to get the number here, someone would definitely know if they were in here, and I'd be like, nice, Morgan, way to go. But anyway, we're going to do negative 6 times negative 6. That'll give us positive 36. okay? So because I wrote in positive 36, really what I did there is I added 36. So I went plus 36. And in order to cancel out plus 36, I need to put a minus 36 out here to keep everything balanced, okay? So minus 36. Okay, so now what I've done here is I fill out the box. Now we can factor, okay? We can factor. So what I can factor out here is just x. Here I'm going to be able to factor out a 6. Here I can factor out x, and here I just factor out 6. Okay, with negatives on the diagonals, I end up with negative and negative. So now this whole thing here turns into x minus 6 times x minus 6, which is really x minus 6 squared, okay? So it's x minus 6 squared, and then we need to just simplify what's going on here, and we're going to eventually have our factored form equation, okay? So 27 minus 36, I believe, is going to be negative 9, so minus 9, okay? So this is our factored form. F of x equals x minus 6 squared minus 9. Okay, so what does this tell us? This tells us our vertex. So we know that, again, like we've done already in this review a couple times, we identify the vertex knowing that it has to do with this number here and this number on the outside, h and k. All right, and so x's do the opposite. So if it's x minus 6, I know that my x value of my vertex is going to be 6. So putting it as x comma y, my vertex is going to be 6 comma negative 9. The y's do not do the opposite. So 6 comma negative 9. And this is nice. I just barely said that I'm going to want my answer to be in, I swear to God, the school's haunted. Creeping me out right now. My answer is going to be in x comma. I totally just lost my train of thought because I feel like I'm about to get ghost murdered right now. So our vertex is a positive x value and a negative y value, so it's going to fit in pretty well over here. Okay, so we go over to 6, 1, 2, 3, 4, 5, 6, then we go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go to about here. This is 6 comma negative 9. And now this is really nice because our whole parabola is going to work out really well. Okay, so we're going to be able to go boom and boom. That's kind of what our graph is going to look like. I guess it's not really nice, but on my paper, it looks a lot nicer. I labeled all those points, and on the paper, it kind of looks like that. Okay. Cool, cool. All right, 5C, this is our last one, and you know what, we're 37 minutes in. We're doing okay. We're doing okay because you guys can pause the video. I don't even feel bad. I'm the one that's here, marathoning through these lessons, and I don't mind it. I'd rather kind of do it that way anyway, so I'm happy with it. I miss you guys, but I don't mind, being here and just teaching for a couple hours at a time because it's kind of fun. As long as I don't end up getting killed by the ghost that's walking up and down the halls. Full disclosure, I don't think that it's actually haunted. It's probably just a maintenance person, but still, it's a little creepy. Okay, so we're gonna do 5C. This is gonna be the last one we do for the SAGE review number 3, Aspire review number 3, whatever you wanna call it. And this is our piecewise functions, which is probably the number one thing I think we struggled with the most this year. So I'm gonna really try to take the time to go through step by step. But it's difficult stuff, and if it's one of those things where you kind of either get it or you don't get it, and I'm going to do my best to sort of break it all down, but here we go, okay? So again, the main important thing to remember here is that we're going to be talking a lot about x intervals, okay? So x intervals, and we're going to start all the way out at negative 7. 1, 2, 3, 4, 5, 6, 7. And we're going to go all the way over to 1, 2, 3, 4, 5. And we'll go up and down about 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So because this is a piecewise function, basically we have two different functions happening here. We have f of x equals absolute value of x plus 3. And this is on the interval of negative 7 less than or equal to x less than negative 3. And we also have negative absolute value of x minus 2 plus 1. Okay, so these are our intervals, and these are the things we care about at the very beginning. So what we're going to do is we're going to cut off those intervals. And we're going to say, okay, so from negative 7 to negative 3, that'll be from here to here. Okay, and so we don't even care about anything to the left of that. That's like the abyss. We just don't even care. There's nothing that is even worth thinking about there, okay? So this is -7 to -3. And we're going to be just graphing this equation, absolute value of x plus 3. So what we can do, if the graphing calculators worked, I would do it on the graphing calculator and show you guys, but because I'm having issues with those calculators, we're just going to kind of have to do this algebraically. So we're going to find points x comma y. So let's remember that this is basically saying y equals that. Okay, so let's start by plugging in -7 for x. Okay, and so that way we're going to have a point that we can label here. So -7, when I put that in for x, I have the absolute value of -7 plus 3. Okay, so -7 plus 3, that's going to be absolute value of -4. And let's remember that what absolute value means is it wants to know the distance away from 0. So the absolute value of -4 is +4. Okay, so this is the y value, whereas -7 was the x value. So now I have -7 for x and +4 for y. Okay, so that's going to be this point here, -7, comma 4. So now let's do the same thing with this end here, with -3. Okay, so we're going to do the same exact thing. We're going to plug in our numbers. And I know that it's hard for a lot of us to visualize this algebraically, so I apologize for the calculators misbehaving, but we got to do what we got to do. So now I'm going to plug in -3. And this is actually going to be okay because when I put in -3 for x, so -3 plus 3, well, that's just going to give me 0. The absolute value of 0 is 0. Thought I heard something out there. Equals 0. I can just label this video like watch Mr. Thompson do math while he thinks he's about to die. Because it's creepy. It's creepy in here, you guys. All right, so when I put in an x value of -3, I get a y value of 0, okay? So -3, comma 0. And I'm going to put an open circle there. Why am I going to put an open circle there, Cadence? Well, you're not here, but I'm sure that you would actually know, and it's because I have this sign. This means just less than. If I have a line under it, like I did over here, then I fill in the circle. But if I don't have the line under it, then we leave it open like this, okay? And now an absolute value graph, we're just going to connect the lines like that. So now let's do the same thing from the interval -3 to +5, but we're going to use this equation now, okay? So we're going to use that equation now, and we care about going from -3 to +5. So again, our bounds are to right here. And we're going to use this equation. So we'll start by putting in -3 again. So I'm going to put so I'm just rewriting this equation with -3 in for x. -3 minus 2 plus 1. Okay, so -3 minus 2 is going to be -5. Okay, and so the absolute value, this means that this is basically, and again, this is like negative the absolute value. So the absolute value of -5 is 5, but I still have this extra negative out in front. So I'm going to end up with -5 plus 1, which is like -5 plus 1, which equals -4, okay? So when I use -3 for my x value, I get -4 as my answer for my y value. So I can go over -1, 2, 3, down 1, 2, 3, 4. And again, I have this sign, so I'm going to fill it in with a filled in dot. All right, now let's do this one more time algebraically for the last point. Where I'm going to use an x value of +5. So +5 minus 2, so let's just plug it in. Negative the absolute value of 5 minus 2 plus 1. Okay, 5 minus 2 is 3, so this is negative absolute value of 3 plus 1. And the absolute value of 3 is just 3, so this is basically -3 because we have the negative in front, plus 1. -3 plus 1 equals -2. So I know that when I have x is 5, y is going to be -2. So that'll be right here, and we're going to have an open circle, okay? And I made the mistake the first time I did this of just drawing a line and connecting them, but that's not actually what we're going to do here because this is an absolute value function, and if we did this in a graph, it would not look exactly like this, okay? It would have a peak somewhere, okay? Because remember, absolute value graphs kind of look like V's. They're like that. More like this, like that, okay? So we need to figure out where that peak is. And the nice thing is we can think of this the same way we thought of our other translations, where we have our x translation in here and our y translation here. Remember, x's do the opposite. So -2 means we're going to be going to +2. So x minus 2, 1, 2, and then we go up 1. Up 1. And so we have a point here. So now we can draw what the graph actually looks like here to here. Okay? So that's going to be the answer that we got right there. And that's basically it, you guys. 45 minutes, that's not horrible. It's a long time, but you know, there's a lot of stuff to cover here. Okay, so if this could freaking focus, there we go. That's what our graph looked like. Okay, so if piecewise functions was not exactly your thing, that's okay. You're gonna probably get a little more of it in Math 3 next year. So maybe your teacher can explain it in a way that makes sense for you a little more at that point. Or you can always ask me questions, guys. I'm happy to try to explain and help you out. So that's it for this video. You'll see me in, you know, a different attire next time because I'm not making any more videos today. That's it for today. That's it for all the Sage reviews. So we're going to be moving on next week. Today is March 26th. And next week, which is going to be like the first week of April, that's when we're going to start our trigonometry stuff, okay? So I'm going to have announcements online with when all this stuff is due, and I will see you in the next video that I hope I have a chance to do because I think there's a ghost here. So I'll see you guys later.